questions that I gave you for today. So the first question there, look, you were told that you have a dye-positive ion, M+2, and that ion has 25 electrons and 32 neutrons, right? And they asked you then to determine the atomic number and the mass number. Now, what do you know about the atom M? Okay, well, because it's a positively charged ion, what does that mean? It means that the atom lost 2 electrons to form the ion, okay? So how many electrons would the atom have had? So at the beginning, it would have had 27 electrons. So that was the number of electrons in the atom. Now, atoms are neutral, remember? So if the atom had 27 electrons, then it also had 27 protons, okay? So the atomic number is the number of protons. So 27, you wouldn't have to actually write that. You would just say 27 is the atomic number. Now, how would you calculate the mass number? Well, the mass number is the number of protons and neutrons. So if you have 27 protons, it told you that the ion had 32 neutrons, so it still has 32 neutrons. When you're forming ions, nothing happens to the proton or neutron number, remember. It's just the electron number that changes when you're forming ions. So when you add them together, look, you're going to get 59. So the mass number is 59, the atomic number is 27, okay? Now, the next thing that they asked you to describe Thomson's plum pudding model of an atom. So what you need to say there, okay, that it's a sphere of positive charge. So the whole sphere is positive. So it's all positive, 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 positive. And then you have these negative electrons embedded at random. So you're going to say a sphere of positive charge with the negative electrons embedded at random. Question 2 then, look, you have an aluminium ion. Okay, and they're telling you it's the numbers 27 and 13. They want to know how many electrons and how many neutrons. Well, again, same thing. What about an atom of aluminium? Okay, and then you're forming the aluminium ion from that atom. Now what happens? Again, look, it's a positively charged ion. So the atom has lost 3 electrons. So you know here, look, the atomic number is 13. So you know that the atom of aluminium has 13 electrons. So to form the aluminium plus 3 ion, what has happened? It has lost 3, so now it has 10 electrons. So the ion has 10 electrons, and by subtraction, so 13 from 27, you're going to say that it's got 14 neutrons, okay? So 14 neutrons and 10 electrons. So there, look, they gave you the numbers. Atomic number tells you the number of electrons and protons in the atom, and then lost 3 because it's a positively charged ion. Question 3 then is a kind of a theory question. So it says, give one way of detecting the presence of cathode rays in a vacuum tube. Well, remember the clip I showed you? You can't see the rays as they're moving through the tube. But you will see a fluorescence or a glow as the rays strike the glass at the end of the tube. So that's what you would say. Naming the scientist who identified cathode rays and also managed to measure their charge to mass ratio. Well, that's J.J. Thomson. And remember, he also put forward the model, the plum pudding model. And then what name was given? So Thomson is your next answer. And then what name is given to the subatomic particle that he identified? Electrons. Now, they didn't ask you that, but you do need to remember that it was George Stoney that gave the name of the electron. Now, B then is a radioactivity question, but they just asked you one of 3 scientists. You're going to say either Mare or Perry-Curie, or you could say Becquerel for that. And then part C there asks you about Rutherford's observations. So what did he say? Well, he said that most of the alpha particles went straight through the gold foil, no detection at all. That was the one result. Again, you can say then that some of the alpha particles, a small number of the alpha particles, came straight back at them, didn't it? And then you had a small number of alpha particles that experienced large angled deflections. Okay, so there were your 3 results. And now you're supposed to, how would Rutherford have deduced from those observations that the nucleus was positive? So how would he know the nucleus was positive? Well, he knew that alpha particles were positively charged. He said that the alpha particles were being repelled by the nucleus. And you know that like charges repel. So you'd have to say something in your answer like, Rutherford knew that alpha particles were positively charged, and the fact that the alpha particles were being repelled, okay, when they hit the nucleus or when they came close to the nucleus, told Rutherford that the nucleus must also be positively charged. How did these observations allow Rutherford to deduce that the nucleus was small and dense. Well, only a very small number were reflected back along their own path, because only a very small number of the alpha particles actually hit the nucleus because it was so small. The nucleus didn't move, remember, it was the alpha particles that were reflected right back along their own path because the nucleus is quite dense. Most of the alpha particles, look, went straight through, which led Rutherford to conclude that most of the atom was in fact empty space and that the nucleus was a very small part of the atom in the centre. Okay, question 4 then. You're asked to find mass number. Well, you know from second year, mass number of an element is the sum of the number of protons and neutrons in the nucleus of the atom. Relative atomic mass, that definition comes up an awful lot. It's the average mass of an atom, okay? You must include the word average. Average mass of one atom of an element relative to 1/12 the mass of the carbon-12 isotope. Because remember, a 1/12 of 12 is 1 AMU. So they're relating the mass of atoms to a 1/12 of the mass of the carbon-12 because that's 1 AMU. They asked you then to list 2 other principles. Now remember, your Victor is a stupid dope. Now they've already given vaporization, and now they didn't mention ionization, so that's one of the processes you'd have to say. Acceleration they have mentioned. Now separation is the other one that they don't give you there, and you must say separation in a magnetic field. They will deduct marks if you don't have in a magnetic field, so make sure you say that. And then listing all the 5 in order. Well, vaporization, ionization, acceleration, separation in a magnetic field, and then finally detection. Now, 60.1% of the sample of galenium was galenium-69, and 39.9% of the sample was galenium-71. They want you to calculate the average mass of one atom of galenium. So remember how you do these. Multiply that by 69, 39.3. Oh, sorry, that's a 9. 39.9 times 71. So when you multiply those out, and then you get 2832.9. Total then for 100 atoms, okay, so that's for 100 atoms. So what would a mass of one atom be divided by 100? And that's a 7, sorry. Okay, so 798, so 69.798. So that's how, remember, decimal places. If you look up the periodic table, some mass numbers of elements are given with decimals. You can't have 0.87 9 of a neutron, but that's where the decimal places come into account. They're average values, taking the isotopes into account, okay? Question 5 there again, look, was the definition of relative atomic mass. That should be fine. Now they're asking you for the number of neutrons of carbon-14. Now remember, carbon is it can exist in 3 different forms. There are 3 isotopes of carbon, carbon-12, carbon-13 and carbon-14. The atomic number of carbon is always 6. Now, our first step all the times is to get moles if it's not given to you. So you need to get moles here. You've been given grams. So the moles would be mass all over the relative atomic mass. So that's 14. In this case, watch it now because it's carbon-14. Don't be automatically dividing by 12. This instance, it's carbon. The mass of carbon atom is 14. So you must divide by the relative atomic mass, which is 14. You have your moles. Now, where are neutrons, you'll ask yourself? Well, you know that neutrons are in the nucleus of the atoms. So you must now get the number of atoms by multiplying by 6 by 10 to the 23. So that's 6 by 10 to the 21 atoms. And then in one atom, how many neutrons would you have? Well, what's 6 from 14? When you subtract, you'll get the number of neutrons in one atom of carbon-14. So it's 8. So one atom has 8 neutrons. So that number of atoms would have 4.8 by 10 to the 22. So 4.8 by 10 to the 22 neutrons in that mass of carbon-14. Okay, thank you.